Morning, everybody. Thank you for the organizers to give me this opportunity to present some background information, some preliminary results from our project on behalf of our modeling team. As you all know, that climate change. Actually, so temperature would be much higher at the end of this century, and Canada warming is twice of the global average. And the worst thing is that global warming also causes changes in climate change. Of course, we are all talking about climate change mitigation and adaptation, and for taking actions, and we need to know what actions to take and how these actions may be effective for mitigation, adaptation, and to climate change and the future climate scenarios. Because climate is changing, and we have to take future climate scenario into consideration. When we are talking about an agriculture production system, we are thinking about diversified crops and crop rotations as both for climate mitigation and adaptation. So, for example, to include those drought-resistant crops, such as on the Canadian prairies, that's semi-arid climate. So those spice crops, something like chickpeas, lentils, they are more drought-resistant. And the warming climate also provide our opportunities, something like grow soybeans on the Canadian prairies, as legumes need less or no nitrogen fertilizer, and that would reduce fertilizer costs and nitrogen loss. I just listed a few those things on this slide, but I don't think I'm going to talk much of those. Okay. Then another thing we are always talking about when we are talking about climate mitigation, so beneficial management practice, BMPs. We also listed a few those BMPs on this slide, such as conservation, tillage, improve the fertilizer application, optimize the manure application, and improve the drainages and irrigation. So there are lots of these BMPs that could be used. However, how we could assess the performance of the diversified crop rotations with so many BMPs? Of course, people would think, okay, so long-term field experiment, that's traditionally effective, but as we know, so these experiments would be labor intensive, time consuming, and expensive. Besides, so we could have very limited number of those combinations with BMPs, and also it's difficult to incorporate with changing climate conditions in these long-term experiments. But of course, these field experiments would be very useful for model calibration, evaluation, and improvement. On the other side, other hand, so crop ecosystem modeling so could be useful in a way when they are well calibrated and evaluated. But these models just simulates only some major processes because the system is so complicated. I don't think a model can do everything. And there are lots of uncertainties associated with model structure, parameterization, and input data. But on the other side, so running these models is less expensive than field experiments, and we could have lots of scenarios with different combinations of crops, BMPs, and the future climate scenario. The objective of our project is to calibrate, evaluate, and improve models for simulating the benefits of BMPs on crop productivity, GHG emissions, and soil carbon in crop rotations. And we would like to evaluate the performance of those typical regional crop rotations on the current and the future climates. And we would like to simulate diversified crop rotations with BMPs on the future climate scenarios to identify region-specific optimal crop rotations with a suite of BMPs for mitigating and adapting to climate change. And then we could make region-specific recommendations for diversified crop rotations. Okay, that's what we want to do, but currently, because we just started the project for 1 year, and we have collected those field experiment data across Canada. Of course, those are historical data, and we plan to use 4 models: DECENT, DNDC, DSAT, and STIX. These models have been calibrated and evaluated for most of those major crops and will be involved in those crop rotations. So we have made some comparison for model performance in simulating crop yields and to emissions in crop rotations, and just at a selected experiment site in Eastern Canada. So we have field experiments at Quebec City in Eastern Canada. This is just one of those experiments. So that deals with a rotation wheat, corn, soybean, and during 2009 and 2018 on a sandy loam soil with different treatments, that's fertilizer treatments, control and no fertilizer applied, and liquid swine manure and liquid dairy manure. And there are 2 tillage measurements, so minimum tillage and inversion tillage. In these experiments, we collected the crop yields, soil organic carbon, and 3 years of N2 emission, soil water, and soil temperature. Yeah, some preliminary results based on 3 models. We currently use the DNDC, DSAT, and STIX for crop yield. So here is an example for wheat, because we have 3 crops: wheat, corn, and soybean. So here, what we are showing is for individual models, 3 models, and as you would see on these 2 treatments, so and not fertilizer treatments. So you could see that the models are doing pretty well for crop yield. And now we are showing the ensemble means from these 3 models, and you could see the ensemble mean could be better for some models, maybe not the best. And these are preliminary results on N2O emission, but this because in the experiment, N2O emission were collected just for 3 years, and actually not every day, and in the growing season. So in 1 year, they collect 23 days, and in other 2 years, 1 year, just 20 days. And the models actually not too bad, although you would see that so relative root mean square error is higher than proper yield for N2 emission. And you would see that so surprisingly, so for N2 emission and the model ensemble from 3 models would be the best than individual model. Okay, so we summarize some of those preliminary results because, as I mentioned, so in these crop rotations, we have 3 crops, and now you could see 3 yield of 3 crops submitted by the model compared with opposite measurements and the ensemble mean of standardized root mean square error on the 2 tillage treatment. And so the ensemble show quite promising results. And I just would like to summarize what we see in these slides. So we thought diversified crops and crop rotations is important for climate change mitigation and adaptation. Crop ecosystem models can be useful tools for assessing the performance of diversified crop rotations with BMPs on crop productivity and the environment on the future climate scenarios. Our preliminary study shows promising results even without the detailed calibration. And I want people to ask that. So if you have already a calibrated model, evaluated model with independence, and unfortunately, we haven't done that yet. And we think different models have strengths and perhaps weaknesses too. And the multi-model ensemble approach may be useful. Thank you for your attention. Thank you.
Okay, we have a question in the back first. Yeah. Yeah.
Thank you. Right now I also work with TNDC model, and right now I have a question that sometimes I don't know if I should use a calibration or not. So I want to ask, do you have this calibration,
Yes, I think calibration is important, and especially so when we involve crop, and so even crop cultivars, different cultivars, and their phenology, their growth rates are different. That would affect the nitrogen processes. No, so we usually don't calibrate solids. That's we use measured data. Yes, only for crops. But maybe Rowan can tell you something about the DNDC. So he's expert on DNDC also. Thank you.
One question here. Yeah. No, your question.
Just go ahead. Thank you.
No, I don't know.
Yeah, I just have a question.
Okay.
Yeah.
Yes.
You mentioned also the Dayton model, but in your sample comparison, this was not included anyway.
Okay, yes, that's our plan. So we are going to use Dayton, but in this preliminary study, we haven't included Dayton yet.
But excluded?
No. Thank you.